Welcome back to our chemistry classmate. So we shall continue few more expected models for the coming entrance examinations. Apart from that, so we are discussing topic wise because based on the students' request. So this is solid state what we are going to learn. For in FCC lattice X, Y and Z atoms are present. X atoms present at corners while Y atoms at the face centers. Okay. One atom of X from a corner is replaced by Z atom. Z is monovalent. Formula of the compound is. So based on the formula, many times they have been asked the questions. We may expect this model also in the coming examinations. It is very simple and important model. So if you take the unit cell, here shall give the shortcut clarification. Suppose if you take the unit cell, corner points they only set the occupied by X. So 8 corners occupied by X. So what is the each corner contribution in one unit cell? 8 into 1 by 8 will get 1 number of effective points. So here X contribution equal to actually 8 into 1 by 8 X, that means you'll get X1. But here they gave one small condition. What is that? One of the corner replaced by Z. That means what is X contribution now? X contribution 7 into 1 by 8 only. Out of 8 corners, 1 corner is Y. That is why, Z. So Z contribution 1 into 1 by 8. That is why X 7 by 8, Z 1 by 8. And this crystal is a FCC structure. Very beginning only again FCC lattice. Is it clear? FCC lattice. Then what is the Y contribution? Remaining points occupied by Y. That means face centers. Mainly in the FCC structure, corner points as well as face centers are main. So face centers, how many faces are there? 6. Each face center contribution how much? 1 by 2. That means one face center is contact with 2 unit cells. So that point is common for 2 unit cells. Hence 6 into 1 by 2 will get Y3. Then what is the formula now? What is the formula? X 7 by 8, Y3, Z 1 by 8. Is it matched? So here multiply with 8. So what will get here? X 7 by 8 into 8 nothing but X7. Y 3 into 8 nothing but 24. Z 1 by 8 into 8 nothing but Z. So that is what is our option? C. Is it clear? So this is one of the important model. Do carefully. Now look at the next question. This is also one of the important model. If NaCl is doped with 10 power minus 3 mole percent SrCl2, what will be the concentration of cation vacancies? Doping. So in generally, if you take the NaCl crystal, so Na plus Cl minus, Na plus Cl minus, Na plus Cl minus, like that. If you take the one crystal, okay, Na plus Cl minus, plus minus, plus minus, plus minus, plus minus, plus minus, plus minus. So in this they are introducing some SrCl2. Actually this is NaCl structure, Na plus Cl minus, Na plus Cl minus, like that. In this they are introducing, see, doping nothing but some other element, other substance introducing. So SrCl2 introduced. How much mole percent? See there, NaCl is doped with 10 power minus 3 mole percent SrCl2. So 10 power minus 3 mole percent. That meaning is what? So concentration of, so I shall do here only. Look at it. Concentration of Sr plus 2, because especially in this chlorine is common in NaCl and SrCl2. Only different ion is Sr plus 2. So concentration of Sr plus 2 equal to 10 power minus 3 mole percent they given. That means 10 power minus 3 by 100 mole. That means 10 power minus 5 mole. Is it clear? 10 power minus 5 mole Sr plus 2 introduced. You know that 1 mole Sr plus 2 contains how many ions? 6.023 into 10 power 23 Sr plus 2 ions. 1 mole Sr plus 2 equal to Avogadro number of Sr plus 2 ions. Now how many moles available? 10 power minus 5 mole Sr plus 2 available. Now how many ions? I mean, if you do the cross multiplication, what will get here? Suppose if you consider this is x, then x equal to 6.023 into 10 power 23 into 10 power minus 5. Then what will get here? 6.023 into 10 power 18 ions. Then what is our option here? 6.023 into 10 power 18. So see there. Is it clear? So it is very simple and important model. 10 power minus 3 mole percent converting into moles. Then what we should do? 1 mole SR plus 2 thing, but Avogadro number of SR plus 2 ions. The 10 power minus 4 how much? So these many moles they can occupy. Is it clear? So we shall go to the next question. So look at the next question. So here this is also one of the important model, very simple model. Tungsten crystallizes. Tungsten, that means you know wolfram, it is W, its symbol is. Tungsten crystallizes in BCC unit cell if the edge of unit cell is 316.5 picometers. Then the radius of the tungsten atom is So it is very clear that they only said that BCC structure, body cubic center. So here edge length A equal to 316.5 picometers given. Okay. In BCC structure, what is the relation between edge length versus radius? Directly had to remember the formula R equal to root 3 by 4 into A. Remember that. In BCC structure, radius versus edge length formula is R equal to root 3 by 4 into A. Suppose if it is FCC, R equal to A by 2 root 2. Is it clear? So R equal to A by 2 root 2 is in FCC. This is in BCC. Now what formula we are supposed to use? This formula. Direct substitution. Very simple. So R equal to root 3 by 4 into A value already given 316.5. So if you simplify this value, you will get nearly 137.04 picometers. Is it clear? Just to do the simplification. So then what is our answer? 137. Is it clear? Okay. Now we shall go to the next question. This is also a very important model. Many times based on the formula with respect to voids. Okay. This is also many times they asked. So it is also very simple. What is the formula of compound in which the element Y forms CCP lattice and atoms X occupies 2 by 3rd of the octahedral voids? O is nothing but octahedral voids. Is it clear? So first of all here we can take X atoms and Y atoms. So X atoms nothing but all corner points. That means what will get here? 8 into 1 by 8. That means X contribution how much? X only. 8 into 1 by 8. Is it okay? What about the Y contribution? Here number of octahedral voids. So if you know the number of atoms, then those many octahedral voids. So suppose in any crystal lattice, suppose this is what they given here, CCP. That means CCP nothing but this is HCP. What is its Z value, effective value? 4. That means 4 atoms. So in these 4 atoms, in any crystal structure, number of atoms and number of octahedral voids are same. But if it is a tetrahedral void, 2 into the number of atoms. So now it is octahedral void only. So how many atoms are there? Those many octahedral voids are present. Is it clear? CCP nothing but HCP structure only, FCC structure only, otherwise. In this Z value 4. Z value 4 nothing but octahedral voids also 4 only. But out of the 2 by 3 only occupied by Y. That means 4 into 2 by 3. What will get here? 8 by 3. Now what is the contribution? X, Y 8 by 3. Is it clear? Sorry, X atoms no reverse. This is Y because compound which element Y forms CCP lattice, atoms of X occupy. X occupies the voids. That is why you can take here it is Y, this is X. Is it clear? Now what will get here? X 8 by 3 and Y 4 because 4 atoms. What is the reason? Y is a CCP form. CCP form nothing but it is 4 atoms. Then what will get here if you simplify? X 2 Y 3. So X 8 by 3 Y 4. If you simplify X 2 Y 3. X 2 Y 3. Is it clear? Is it okay? Okay. Next, look at the next question. This is also one of the important model. So an ionic compound AB2 possesses CaF2 type. CaF2 nothing but fluoride structure. You know that CaF2. The coordination number of A plus 2 and B minus ions respectively. So coordination number nothing but see A plus 2 ion, cation surrounding by how many anions? How many anions? Similarly B minus nothing but anion surrounding by how many cations? That is only coordination number. You know that. How many ions, opposite ions are keep in contact with that. So you know in the fluoride structure it is very clear. Some important points I shall remind you here. First of all, fluoride it is AB2 type. AB2 type, and example is CaF2, and its packing. If you observe that Ca plus 2 are occupies Ca plus 2 are occupies at the corners and faces. Remember that corners and faces in fluoride structure or in AB2 type structures. Ca plus 2 cation occupies at corners and faces. Okay, F minus occupies at voids, especially on what place it is attached. For example, if you take this is the simple unit cell. Okay, at body diagonal very close to this corner and very close to this corner. Here one fluorine minus and here one fluorine minus. That means here one void and here one void will be formed. Like that in one unit cell, how many body diagonals are there? Four body diagonals. So generally, if you take one crystal lattice, in one body, in one unit cell, one body diagonal in this way. Similarly, how many possibilities are there? Four possibilities are there. That means four body diagonals. Four body diagonals, nothing but how many? 8F minus. 8F minus. Is it clear? So A plus 2, that means here Ca plus 2 is surrounded by 8F minus, and B minus, that means F minus surrounded by 4 Ca plus 2. That means 8 comma 4. Is it clear? So in CaF2 or AB2 type structures, each cation surrounded by 8 fluorine. Is it clear? Why it is 8 fluorine? Because if you take this corner, surrounding 8 unit cells are there. You know, one corner point linked with 8 other unit cells. So very close to one void here. Similarly, 8 voids surrounding of one core 8 voids. Is it okay? So this corner point is Ca plus 2. This is linked with 8 other unit cells. If you imagine the complete structure of this unit cell. So very close at the body diagonal place void is present. That means there F minus is present. Like that, how many surrounding to this? 8F minus. 1 Ca plus 2, 8F minus. Similarly, 1 F minus surrounding by 4 Ca plus 2. If you take the original structure, you'll get the clarity. Is it clear? Right. Now look at the next question. This is also very important model based on the words only, very simple. A compound form HCP structure. The total number of voids in 0.5 mole of compound is. Do you understand the question? Very simple. Compound form HCP, that means generally FCC. Total number of voids. So you know 1 mole of any substance contains 6.023 into 10 power 23 atoms. Is it okay? Now here what they given? 0.5 mole. 0.5 mole nothing but how many? 3.3 some. If you remove this, if you consider as a significant figure, it is a 3 into 10 power 23 atoms. Is it okay? So if you consider as x, if you do the cross multiplication, you'll get this one, half mole. So you know in any unit cell, in any crystal lattice, how many atoms are there? Those many octahedral voids are present. Suppose in any unit cell, if x are simply n atoms are there, then how many octahedral voids? N only. How many tetrahedral voids? 2n. I think this is the, you know, this is the basic formula. Is it okay? Now in 3 into 10 power 23 atoms, how many octahedral voids? Same number. In 3 into 10 power 23 atom unit cell, how many tetrahedral voids? Double this. That means 3 into 10 power 23 atoms occupied by octahedral voids. 6 into 10 power 23 atoms occupied by tetrahedral. So 3 into 10 power 23 plus 6 into 10 power 23. What will get? 9 into 10 power 23. Is it clear? Very simple and very important model. Now look at the next question. So based on the density, many times they asked the question. So especially two types of questions are there here. So copper crystallizes into the FCC lattice with edge length 3.61 into 10 power minus 8 centimeters. The density of the copper is copper atomic weight given and copper number of means Avogadro number given. So generally we know the term. So here edge length nothing but A value given. This is A value. Okay. Crystallizes FCC. FC is nothing but indirectly they are given that Z equal to 4. Is it okay? Now what is the formula? Density formula direct D equal to Zm by A cube into N. You know that. Very simple. So Z value how much here? 4 into M nothing but 63.5 by A nothing but here 3.61 into 10 power minus 8 centimeter whole cube. N replace the Avogadro number 6.023 into 10 power 23. Now if you simplify you will get just do the simplification 8.96 nearly you'll get. So 8.965. Direct substitution, direct formula. So previous questions if you observe that in examination maximum they are given the direct formula related only. But different terms. Suppose sometimes they will give the density, M value, A values, they will ask the Z value. Here how many variables are there? D is variable, Z is variable, M is variable, A is variable. So generally Avogadro number is fixed. Is it okay? Right. Now look at the next question. So silver crystallizes in FCC lattice if the edge length of the unit cell is 4.077 into 10 power minus 8 centimeters and the density of the crystal is 10.5 gram per centimeter cube, then the atomic mass of the silver is. Now here what they asked, M value they asked, same formula. So D equal to same formula, Zm by Zm by A cube into N, same formula. Now here which one they asked? They're asking about the mass M. This is also directly substitution only. So here what will get? M equal to D into A cube into N by Z. So D nothing but how much given? 10.5. A value edge length how much given? 4.077 into 10 power minus 8 whole cube. N nothing but Avogadro number. Z nothing but what structure it is? FCC structure. They only said FCC structure. What is the Z value? 4. So if you simplify the value, you will get nearly 107 point something, means 108. You know, for this kind of questions, if you think logically, sometimes atomic weight if they're asked, if you have the idea about the atomic weight without solving also we can guess it. If options are somewhat different. So is observe here 47, actually 47 is the atomic number of the silver. If you confuse it, if you select it, it is wrong option. Suppose 198 it is atomic weight of the gold. Okay, so generally if atomic weight are asked, if you have the idea about the atomic weight without solving also we can guess it. So then it is a time saving matter. Is it clear? Right. We shall go to the next question. This is also very simple, very small logic question. Which of the following will not adopt CSCl structure, cesium chloride structure? So cesium fluoride, cesium bromide, cesium sulfide, cesium cyanide given. So CSCl structure and means among these four which is not related to that. Very small logic, simple logic, ultimately it is A. What is the reason? Cesium size is like this, fluorine size is like this. Is it okay? But remaining cases somewhat comparable size, but it is size is not comparable. That is why definitely it is not like a CSCl structure. Remaining are somewhat comparable. So CS versus bromine, CS versus sulfide. So some comparison is there. Is it okay? Right. Next question see there. This is also one of the important model. If the distance between Na plus and Cl minus ions in NaCl crystal is A picometers, what is the length of cell edge? So very simple question. Here they are asking about the NaCl structure. So if you take the simple crystal lattice one unit cell, if you take the unit cell, observe here, this is one unit cell. Now this is this is one Cl minus, because Cl minus size is somewhat more. In between these two, sodium will present like this, Na plus. Now in between these two, the distance what they said, A picometers. Here also A picometers. Here 1A and here 1A. Total how much? Then 2A picometers. Is it okay? So very simple model. Now look at the next question. So Bragg's equation, this is based on the Bragg's equation. Actually, in the NEET point of view, Bragg's equation questions are, up to now they were not asked anything anytime. But mains point of it is very important because it is a simple model. A second order Bragg's diffraction X-rays with lambda equal to 1 angstrom from a set of parallel planes in a metal occurs at the angle of 60 degrees. The distance between the scattering planes in the crystal is. So if you know the experiment of the Bragg's equation, you will get the answer very easily with a short span of the time. If you are aware about that, you will get very easily. Otherwise, you remember this formula. What is the formula for the Bragg's equation? N lambda equal to 2d sine theta. So here n nothing but order of the diffraction. Now here they are asking about, so n value given, lambda value given, and some angle of the plane also given, but they are asking about the d. That is why what you can get here, d equal to n lambda by 2 sine theta. Is it okay? Now here n nothing but second order, they only said 2, and a nothing but angstrom units already given 1 angstrom lambda value. Okay, 2 into sine theta nothing but sine 60. Then if you simplify, you'll get to 1.15 angstrom units, because this is 1 angstrom unit. Yes, is it clear? 1.15. This is the correct answer. So Bragg's equation questions are very simple if you remember the formula. So in this, sometimes they may ask about the n value, sometimes lambda, sometimes distance, sometimes theta also. These are the variables. But in the NEET point of view, they were not asked. But if chances are there, just remember the formula. But mains point of view, definitely you may already you learnt this experiment, I think so. You are aware about this formula.